Today's learning target is I can find the area of composite figures. So what is a composite figure? Well, a composite figure is going to be a figure that's made up of two or more shapes. So take a look at this figure that we have here and just take a second and think, what shapes do you see in this figure? So perhaps here you saw three shapes. You've got a triangle right here. We have a semicircle, right there, and then that leaves us with a rectangle. So we can look at that here, and we can see that in the picture to the side. We've got our semicircle, we've got our triangle here, and we've got a rectangle. And because we've talked about how to find the area of all these different figures, we could find the area of this composite figure. First thing that I want to do when I'm finding the area of a composite figure is to take a look at the shapes and try to break them into shapes that I can find the area of. So let me give you an example here. If I were to draw a line right here, I now have a rectangle right here. I know how to find the area of that. And I have a trapezoid here. Okay, it has one pair of parallel lines. I could find the area of that. Another way I could break it up is this way. Now I have a rectangle here, right there, and I have a triangle right here. Now I'm going to choose to find the area this way because this one seems simpler to me. But I could have used this figure. You can see I wrote down the formulas. In this case, here's the formula for this trapezoid, and here's the formula to find the area of this rectangle. Okay, I could solve it that way, but like I said, this one to me seems like it'll be a little simpler, so I'm going to take the area of a triangle, which is right here, and I'm going to add the area of this rectangle right there. So the first thing I'm going to do is find the area of this triangle. Now, these kind of problems become almost like little mini puzzles. Okay, so here's what I know. I know that from here to here in the triangle is 10 feet. Right there it says 10 feet. But if I look over here, I see the distance from here to here is 4 feet. So that means my distance here to here is also going to be 4 feet. So now I'll use what I know. So from here to here I know is 10 feet. If this here to here is 4 feet, the rest of the way has to be whatever is going to make it equal 10 feet. So that leaves me with 6 feet over here. So now I've found the height of my triangle, which was one of the things I need to find. Now I need to find the base. The base of my triangle is going to be right here. Okay, well I'm going to do the same thing. From here to here is 12 feet. So that means I know it's 8 feet. It says it right here, 8 feet from here to here. I'm going to have to make this 4 feet. Because now, if this is 4 feet and this is 8 feet, this distance is 12 feet, which is what it says over here. So I've just found my base. So over here you can see I've written down my formula for the area of this triangle is going to be 1/2 the base times height. I plugged in my numbers. Here's my height, here's my base. So I get half of 24. So that means my area for that triangle is going to be half of 24, which is 12 square feet. Okay? So that means in here I get 12 square feet for the area of this figure. But now I'm not done. Now I need to find the area of the rectangle. Okay, so that's going to be now this figure. So the area of my rectangle here is going to be a little easier. I remember that area of a rectangle equals length times width. My length is 12, my width is 4. I plug those in. And when I multiply those, my area equals 48. And again, it's area, so it's square feet. So the area of this figure is 48 feet. Now all I do is I add the area of the triangle, which was 12 square feet, and the area of the rectangle, which was 48 square feet, and the total area is going to be 60 square feet. So if you feel like you have a good understanding of how to find the area of a composite figure, you can go ahead and start on your assignment today. I'm going to show you right here, if you want to see, how to find the area of a composite figure with a semicircle. It's the same thing, it's just dealing with couple different types of shaped figures from the last one. So when I look at this figure, I'm going to break it up into 3 parts this time. So here's a semicircle, half a circle here. Here's a semicircle, half a circle there, and then I'm left with a rectangle here. So I'm going to start off with the easier figure here. I did the rectangle. I saw the rectangle right here, and I remember area equals length times the width for a rectangle. Plugged in my numbers. Here was my length, 12 feet, my width, 6 feet, and my area of that figure was 72 square feet. So now let's take a look at the area of the circle, okay, or the semicircle in this case. So remember, area of a circle is going to equal pi r squared. But notice there's semicircles, right? So it's going to be half pi r squared to find the area of this figure right there. So I plugged in my numbers to my formula. I knew the radius was 3 because the diameter was 6. Radius is half of that. So I plugged in the 3 for the radius. And then I did 3 squared, which was 9, times it by 3.14, or pi. And I got 28.26. And now I have to take half of that because this is the area of the full circle. This is a semicircle, or half a circle. So I take half of that. So when I figure out half of 28.26, I get 14.13. So that's the area of this semicircle. Now if you notice, this semicircle has the same dimensions. So that is also going to have an area of 14.13 square feet. Okay, so I'm going to add up the 72 square feet, the 14.13, and the 14.13 here. Now once I add those together, the area for those 3 figures, I get 126 hundredths square feet.